Hello, welcome back to RC Video Reviews. When I started looking at the Jumper T18 lineup, one of the standout features they advertise are these Alps RDC90 sensor gimbals. I thought, wow, that sounds impressive. An Alps RDC90, that must be cool. They charge more for it. So I went out to the internet and started looking and trying to understand what do you get when you get an RDC90 gimbal, and I can't believe how much bad information is out there. So let's cut through the crap and talk about what you actually get when you buy a radio with RDC90 gimbals. I'm going to break up the subject matter into 5 pieces. First, we'll talk about Gimbal Elements. Then I'll explain to you what an RDC90 is. We'll take a look at the difference between an RDC90 and Hall effect sensors and gimbals. Then we'll make a comparison between the T18 Pro, the TX16S, and the T18 Lite. And then I'll let you know which one I think is the best. The thing to take away from this slide is that all of the gimbals in this comparison use bearings, they all use springs, and they all have spring tension. Spring tension is one of those subjective issues, and it's why every radio on the market allows you to adjust spring tension. You can see these screws on the bottom left. Those are all there so you can adjust your spring tension. And then you can also go out and buy different springs. In fact, most of these radios come with a second set of springs. So spring tension itself, how hard or how soft the stick is, that's purely subjective. And we can't really address subjective points of view in the video because there's always going to be somebody on opposite sides of the fence. Same thing with bearings. Since all of these gimbals have bearings, there is no quote-unquote feel. They're all using bearings. So as long as every one of them is riding on bearings on the vertical and horizontal axis, and they all have some spring tension, they're all going to be adjustable within some range or reason. For my purposes in the rest of this video, I'm really not going to spend any more time talking about how they feel because frankly, you can adjust how they feel. The main thing is whether or not they're using quality bearings, and I can say from using both the Radiomaster and the Jumper, the bearings are fine. It comes down to spring tension and spring weight, and that's it. The bottom line here is that if your sticks are too light, tighten the spring. If they're too hard, loosen it. If the range is wrong, get new springs. The truth is that nobody can answer this but you. All right, next up is what is an RDC90? I hear all the time people say, I got me some RDC90 gimbals, or let's take a look at the RDC90 gimbals. They're always referred to as the RDC90 gimbals, and I guess that's because that's the way Jumper puts it in their marketing material. But the reality is a gimbal is just a gimbal, and RDC90 is just a sensor. It's not a gimbal, okay? The term RDC90 refers to a sensor made by Alps. The T18 Pro does use different mechanical gimbals from the Lite and Standard versions. We'll get to that in just a minute. One of the telltale signs of the gimbals used with the RDC90 sensor is they've got the adjustable screw on the front of the radio case that allows you to adjust the tilt of the sticks. More important than all of that is that the RDC90 is not a Hall effect sensor. It's funny how the internet blew up when Fursky came out with the Hall effect sensors. You could see, just Google it, you'll see quotes all over the place. Oh, they're more precise, there's no more mechanical linkages, they're longer lasting than pots, they're not subject to dust or moisture which can ruin the pots. So Fursky comes out with these M9 Hall effect sensors and it broke the internet. So what's killing me, or what I find most humorous about this, is that the RDC90 is going back to a mechanical pot. Now on this screen, there are a couple of things that I want to point out. Notice the green circle at the bottom. It says operating life cycles, 10 million. Well, that sounds impressive. That does sound impressive. I'll address that a little later, but keep that number in mind. And then the other thing I want to point out is this number called linearity. You see how it says plus or minus 3%? Keep that in mind too. We're going to address that later. But this is the data sheet for the Alps RDC90, and these are the key specifications I could find on the sensor. The main thing that they seem to claim here is that it's a long life sensor, and I think they indicate that by showing the operating life cycle is 10 million. If you compare that to the RDC50 above, that's only 1 million. I pulled up a data sheet for a Texas Instruments Hall sensor, and the voltage and sensitivity lifetime drift on those, they indicate a high temp operating stress for 1,000 hours for a lifetime. I don't know how you compare a high temp operating stress of 1,000 hours against an operating life cycle of 10 million. But what I can say is that Hall sensors don't have mechanical linkages. So I have a feeling that they're gonna last an awfully long time. And that's been the claim on the internet ever since Firsky came out with the M9. In this slide, if you look on the right-hand side, I'm trying to show you what that RDC90 looks like in practice on the Jumper T18 Pro. Unfortunately, I do not have a T18 Pro, so I can't get you a picture on my own, but that's the sensor. And you can see those 3 pins, those hold that potentiometer onto the circuit board. And the axis goes right up through the middle in that little blue area, and that's what gives feedback from the stick to the electrical circuit. I've got to give a shout out to Bruce over at RC Model Reviews. He took a really nice side-by-side picture of the Radiomaster TX16S and the Jumper T18 Pro. Again, since I don't have a Pro model, I couldn't produce this picture, so I had to go find one. So all credit to Bruce, and I'll put a link in the description to this video so you can go watch this video if you'd like. However, I did annotate this, and I've got points 1 through 5 I'd like to cover, just so you can get a comparison of the differences between the TX16S gimbals and the Jumper T18 Pro gimbals. If you look on the right-hand side at point number 1, there's a tension bar that's made out of metal on the TX16S. And if you look at number 2 on the left-hand side on the Jumper, that same tension bar is made out of plastic. For me, that's a win on the TX16S side. Number 3 refers to the leaf springs used on both radios for the throttle ratchet mechanism and throttle tension. And you can see by this picture, they both use a metallic leaf spring. So that's a draw, in my opinion. Number 4, again, is a reference to the RDC90 potentiometer. And number 5 is a reference to the Hall effect sensor used on the TX16S. On this slide, if you look at reference point number 1, you'll see that that is a Hall effect sensor on the right-hand side. If you look at point number 2, you'll notice they use plastic tensioners and bearing caps. The bearing caps hold the bearing into their galleys, and underneath that plastic tensioner, there's a metal leaf spring similar to the one on the TX16S and the Jumper 18 Pro, but it's shorter. On this slide, you can see the Hall effect sensor in place. The magnet is on the bottom and the sensor is on the top. Next, we're going to talk about the specifications, and I want to remind you of this slide. This is the data sheet I put up on the RDC90. I just wanted to remind you of that 3% plus or minus linearity. Here's the definition of sensitivity linearity that I found in the Hall effect sensor data sheet by Texas Instruments. It says the device produces a linear response when the voltage is within the specified range. Outside the range, sensitivity is reduced and non-linear. So remember what I said, 3% plus or minus linearity on the RDC90, and check out what it is on a Hall effect sensor. On the Hall effect sensor, it's plus or minus 1%. So if you take operational longevity out of the equation, because we really can't compare 1,000 high stress hours against 10 million cycles, I don't know how you compare those two. The only thing really left to focus on is the linearity error. And on the RDC90, it's plus or minus 3%. On the Hall effect sensor, it's plus or minus 1. One caveat here, I don't know if this is the chip used in the radios. The chips are so small, I can't figure out what's printed on them, so I don't know what chip they're using. However, I'm going to make an assumption that since a Hall effect sensor is not a mechanical device, it's an electrical device, that it's going to be more accurate. And that goes back to the original point I made about Firsky blowing up the internet when they first released the M9 Hall effect gimbals. Everybody went crazy about how sensitive and how precise they were. It's time to cut to the chase. Here's the conclusion. I do not see value in the RDC90 gimbals because they are not mechanically superior to the TX16S gimbals. In fact, they're inferior because they use the plastic tensioner arm where the TX16S uses a metal arm. Other than that, we're back down to the bearings and springs question, and I'll argue that no human can tell the difference on bearings, and if the springs aren't right, tighten them or loosen them. All we're left with is the idea that the TX16S uses better hardware. That's it. Regarding the RDC90 sensor, the only meaningful published specification I can find shows that it's inferior to a Hall effect sensor. So I don't know why anybody would want an RDC90 over a Hall effect sensor. If you're an electrical engineer and can explain it to me, I'd love to hear the answer. I'd love to hear the answer. But this is one of those topics on the internet that has been completely glossed over. The RDC90 is not a Hall effect sensor, and I don't understand how it can be considered more precise based on the data I've been able to glean from the data sheets. Regarding my choices in the jumper lineup, this is real simple to me. The R9 implementation is not good. There's no telemetry. It's got a reduced output, and flex firmware is required on your R9 receivers. Regarding the RDC90 gimbals, I seriously question whether these are superior in any way whatsoever. Regarding the standard and light iterations of the T18, again, they both use bearings and springs. The only real difference I can find mechanically is that there's a plastic bearing cap. But so what? As long as you're not mistreating the radio, that bearing cap's going to last forever. With the light version of the jumper radio, you're not paying for R9 and you're not paying for the quote-unquote upgraded gimbals. I don't have any idea why anybody would buy the pro version of this radio. Get the light version, save your money, and buy a crossfire module. You'll have a better setup. On the TX16S, they're mechanically no worse than the RDC90 gimbals. In fact, they're slightly better because they have that metal tensioner arm. Until someone comes up with a reason not to, I would take a Hall effect sensor over an RDC90 sensor in a New York second. For me, the winner is simple. It's the TX16S. It has the better electrical arrangement using the Hall effect sensor. It's got good bearings. It's got metal spring tensioner arms. And I can't find a single reason that the jumper T18 Pro Gimbals are better than the TX16S. Hey, if you like this kind of content, I would definitely appreciate your subscription. Just so you know, a full 63% of viewers on this channel don't subscribe. It'd be nice if you're a recurring visitor to hit that subscribe button and help the channel grow. For the rest of you, please keep the engagement coming. Comment, thumbs up. Make sure you leave a thumbs up if you like the video. If you don't like it, leave a thumbs down, but tell me why. Make sure you check my affiliate links in the description if you need to buy something on Amazon or Banggood. That's all I've got for today, guys. Take it easy. In this video, I've got 4 things. Oops. I want to remind you on the spec sheet. So next we're going to, okay. In fact, they're inferior. They use, in fact, they are, that's hard to say.